when you look at the seafloor today, it's quite likely you would see something like this. Provided there's enough oxygen and organic matter available, there's a wide variety of animals that take advantage of the seafloor, either by living on top of it or actually burrowing inside and living inside of the sediment. Now, the presence of bioturbation or the presence of these animals has a very large impact on the transport processes within these sediments. If you look at a non-bioturbated, just defined laminated sediment, what generally happens is that particles arrive from the top and they get transported down very slowly by sedimentation or compaction, while dissolved species are diffusing based on the differences in concentration within the pore water. Now, if you add animals, you add bioturbation, what they will do is they will start burrowing, they will start constructing burrows, and because of this movement and this feeding, they actually transport solid phase particles much more efficiently. Additionally, when they have burrows, they have to oxygenate it, so they have to flush in oxygenated overlying water through the burrow and flush out the anoxic pore water. Thereby, they strongly enhance the transport of the dissolved species. Now, this strong increase in transport also has a very big impact on the biogeochemical cycling within the sediment. If you compare these two sediments, one is a bioturbated one is an unbioturbated one, you can immediately see that there's a very big difference in appearance. The bioturbated one has a strong, relatively thick iron oxide rusty layer on top, which changes into dark, which disappears with depth, while the unbioturbated one is black all the way through. Now, this dark color is very indicative for reduced mineral, for reduced iron sulfide. And indeed, when you analyze the sediment, what you see is that there's much more reduced sulfur within the unbioturbated core. So this means that actually the presence of bioturbation oxidizes the seafloor. So they increase the oxygen consumption of the sediment and they prevent the buildup of reduced minerals. Now, given this big impact on today's geochemical cycles, the question is what happened when when the ocean changed from an unbioturbated seafloor to a bioturbated seafloor, which is what happened during the Cambrian explosion. When in the Neoproterozoic, before the evolution of multicellularity, the seafloor was unbioturbated, there were plenty of microbial mats, while afterwards, by the end of the Paleozoic, some 100 million years later, the seafloor was colonized by burrowing fauna and was very much affected by bioturbation. So the question is what happened in between. Now, studies have shown that actually the evolution of the intensity and the depth of bioturbation has occurred very gradually, with depths only a fraction of what it is today, the today average being 10 centimeters. However, when you look at diagenetic modeling, what you see is that actually the main geochemical impact occurs when we go from no bioturbation to a very little bioturbation, which means that those very small depths at the beginning of the Cambrian actually had a very large impact on the geochemistry. And indeed, when you put this in a very large model, a very Earth system model, which models basically the biogeochemical cycles of the whole world, you see that when bioturbation evolved in the Cambrian, it triggered an increase in CO2, so it triggered a global warming event, and it also increased the intensity of ocean anoxia. So basically, when bioturbation evolved, started colonizing the seafloor, they also made their ocean, so the oxygenated water they need, to make it anoxic. So to sum up, basically, bioturbation stimulates the oxidation of the seafloor and increases the sedimentary oxygen uptake. Today, the small increases in bioturbation intensity are actually what makes the larger geochemical effects, and the evolution of burrowing could have contributed to global warming and an increase in ocean anoxia during the Cambrian explosion. And with that, I want to thank everybody who helped with this research, and I'll leave you with the conclusion slide. Thank you very much.